Fernandez. Here is Professor Zanconati with me.
Good afternoon.
Fantastic.
I was saying that I already met Professor Zanconati in Trieste. I don't know if he remembers or not. We have here some of the students attending this meeting.
Here there are 17 students and your students, so we can start now if you agree.
We start with the first presentation. We have prepared a video with a comment in Portuguese with the subtitle in English, okay, about the activity of the students in Erasmus period, okay?
Great.
Good.
Let's start.
Este é o edifício onde se encontra o Serviço de Anatomia Patológica do Hospital de Catinara. O edifício é composto por 4 pisos nos quais estão distribuídos os diferentes serviços. Aqui encontra-se a entrada do Laboratório de Anatomia Patológica. Nesta área do laboratório é realizada a recepção das amostras.
As amostras chegam ao laboratório de vários pontos hospitalares de Trieste, sendo transportadas em sacos térmicos. As amostras são colocadas na câmara de pressão negativa e assinala-se a chegada tocando na campainha. Os técnicos recolhem o saco da câmara e retiram as amostras. Dentro da Câmara de Segurança Biológica, confirma-se os dados constantes na ficha de requisição com os da amostra.
No laboratório de citologia são recebidas amostras ginecológicas e não ginecológicas, como lavados, escovados, urinas, líquidos cavitários e biópsias aspirativas por agulha fina. As amostras ginecológicas para a realização do teste Papa Nicolau são colhidas para um frasco de Preserve Sheet e processadas pelo equipamento ThinPrep 5000 Deologic. Consoante o número de amostras colocadas a processar, deve-se ter em atenção se existem filtros, lâminas e recipientes com álcool a 95% suficientes. No decorrer do estágio, é de salientar a importância do apoio dos monitores para que seja tudo feito corretamente. As amostras de urina são recebidas em citolite em 3 tubos de Falcon e centrifugadas para concentrar o material celular. Após, é efetuada a decantação do subnadante, etapa que requer atenção e cuidado para que o pellet não seja descartado. De seguida, é adicionado cerca de 30 ml de citolite a um dos tubos para lavagem do material celular.
A coloração das lâminas de citologia ginecológica e não ginecológica é realizada no equipamento automático, pela coloração de Papa Nicolau. Posteriormente, a rack das lâminas é colocada no equipamento de montagem Leica CV 3050. Quando finalizado, as lâminas são colocadas por ordem no suporte.
Depois de todas as amostras de urina terem sido decantadas e ter sido adicionado o Cytolite, são colocadas a centrifugar. A colocação das amostras na centrífuga deve seguir uma disposição em espelho. No laboratório de pesquisa de HPV é realizada a extração de DNA a partir de amostras ginecológicas em base líquida. O primeiro passo é homogeneizar a amostra e retirar as tampas de todos os frascos para serem colocadas nas racks. De seguida, as racks são colocadas no equipamento Cobas 4800 e repõem-se os consumíveis, como por exemplo a microplaca de extração e pontas de pipetagem. No sistema operativo é selecionado o programa a utilizar e o equipamento recolhe as amostras e os consumíveis. Após, repõem-se os reagentes necessários para a extração, que são colocados numa posição específica no equipamento para posteriormente serem recolhidos.
Na área de recepção de amostras, as mesmas são recebidas acompanhadas pela ficha de requisição. A data de colheita e de recepção no laboratório são inseridas no sistema informático APSIS e é atribuído o número interno às amostras. Após as amostras serem aceitas com o número interno, as requisições são levadas para a secretaria.
Na área de macroscopia, é possível observar os patologistas a realizarem a descrição macroscópica das peças cirúrgicas e biópsias, assim como a sua amostragem. O técnico de anatomia patológica auxilia no registro da descrição macroscópica e amostragem. Peças cirúrgicas recebidas a fresco após descrição e material não utilizado após descrição e amostragem, que ainda requer fixação, são colocadas em formol tamponado a 10% num saco a vácuo. Os sacos com as amostras são colocados no armário, que está organizado pelos tipos de amostras. No final da rotina, as biocassetes são registadas no sistema informático APSIS, na secção Processamento. São escolhidos o processador e o programa consoante o tipo de amostra.
A partir do sistema informático APSIS, insere-se o número da amostra e selecionam-se os tipos de lâminas a identificar. A identificação é feita por impressão do número e código QR da amostra pelo equipamento Leica IPS. As lâminas são recolhidas e colocadas junto das requisições.
Na sala de inclusão, procede-se à inclusão dos fragmentos em parafina. A explicação do monitor permite aprender e recordar como incluir os fragmentos. Assim, adquire-se autonomia para integrar a equipa e auxiliar na rotina.
Na inclusão manual dos tecidos, o molde deve ser escolhido de acordo com o tamanho do fragmento. É colocada a parafina líquida e é feita a orientação do mesmo na placa quente. Depois, é colocado no ponto frio para a solidificação parcial da parafina, pressionando uniformemente o fragmento, e é colocada a cassete. Por fim, o molde vai para a placa fria a menos 10 graus.
Quando o bloco de parafina se solidifica, é destacado do molde. Segue para que os excessos de parafina à volta da biocassete sejam limpos por meio de aumento da temperatura.
Após a obtenção do bloco de parafina, é dada a entrada do mesmo no sistema informático e todos os blocos são ordenados no suporte. A inclusão automática dos tecidos é realizada no equipamento Sakura. O suporte com as cassetes processadas é colocado no equipamento após a inclusão. São retirados os blocos de parafina e é dada a entrada no sistema informático com uma inclusão Sakura A120.
Depois de todas as biocassetes serem retiradas do suporte para a inclusão, os suportes são colocados a limpar no processador Donatello.
Aqui está a ser executada a substituição dos reagentes dos processadores Donatello. O reagente a ser substituído é retirado do equipamento. É realizada a leitura do código RFID do reagente a ser substituído e do reagente novo. Após a colocação do reagente novo, é realizado um self-check pelo próprio equipamento.
No fim da rotina da inclusão, os moldes metálicos são colocados no processador para limpeza. Aqui é a sala dos exames extemporâneos e observa-se o monitor a explicar o processo realizado. Dado ser um exame de urgência e que requer rapidez, não é executado pelos alunos.
As lâminas com os cortes aderidos são colocadas no suporte de coloração e inseridas no equipamento automático. O número de lâminas presentes no suporte deve ser colocado no sistema como se observa. Após isso, a coloração da hematoxilina e usina prossegue automaticamente.
Aqui, observa-se a reposição das lamelas no equipamento de montagem automático. Após o término da montagem das lâminas, retiram-se as racks. Distribuem-se as lâminas nos suportes, consoante o técnico que executou os cortes histológicos.
Cada ficha de requisição é inserida no sistema informático Apsis através da leitura do código de barras para introduzir a informação que este foi seccionado.
Aqui observa-se o monitor ao micrótomo para a obtenção da ténia.
Após a obtenção da ténia, esta é colocada no banho para retirar as pregas de maior tamanho e estender. Com o auxílio da lâmina a 90 graus, o corte é apanhado e aderido. Para obter a ténia, primeiro é feito o desbaste do bloco a 20 microns. De seguida, é mudada a secção da faca e é feito o corte a 3 microns, de forma gentil e soprando na direção do ângulo da faca. A ténia é colocada no banho com o auxílio de um pincel. O Laboratório de Imunohistoquímica está equipado por diversos equipamentos capacitados para diferentes processos. Aqui, observa-se a adição de reagente para a diluição dos anticorpos concentrados, que segue uma concentração específica para cada anticorpo que consta na lista. Neste equipamento de imunohistoquímica, primeiro é observada a lâmina para verificar que a coloração está correta. Posteriormente, a mesma é colocada na rack. Após isto, a rack é inserida em álcool a 95%, de seguida em álcool absoluto e em xilol. Por fim, as mesmas são colocadas no equipamento de montagem.
Aqui há a oportunidade de realizar estágio em tanatologia. Para garantir todas as medidas de segurança e proteção, é de extrema importância o uso de EPIs.
E como nem tudo é trabalho, todos os dias temos o nosso tempo de pausa e convívio.
Okay, great job. Let's go on with the next presentation, okay?
The following video has been recorded in the Cytology Lab of Cattinara. I prepared the rotor for the thin prep processor, where I put the cytologic sample that is inside the vial with a white cap, the slide and a filter, which will be green if it is urinary cytology sample or transparent if it contains genealogical sample. The slide is labeled with the same barcode of the sample.
The samples arrive in a closed bag with their own application and I check the match between them. For every application, I enter in the PC the type of sample, which is a CIT as cytologic, the date of sampling and the number of the sample. Then I generate a unique code to identify the sample. I write on the application the sample's volume and the macroscopic aspect. Then I label on that the generated barcode.
I print two labels. I stick the first one on the Falcon, which contains the sample, and the second one on the 10 mm vial, where I put my sample after having centrifugated it, removed the supernatant, and having added formalin.
Here we shift to the Histology Lab. In this lab, pathologists and laboratory technicians work together to collect relevant samples from the biopsy. I put on the computer the descriptions of the organs that the pathology previously delivered. Advices for a better laboratory routines are then exchanged between the two sides.
Once sampling is complete, the material contained in a plastic bag must be stored in one of the following ways: either under vacuum or under vacuum with formalin through the seal-safe machine. I scan the barcode of the bag. Then I put the bag containing the sample under vacuum.
For the samples that have not been fixated optimally, I put the bag in formalin under vacuum.
In this area of the laboratory, the paraffin embedding of biopsies and autoptic samples takes place. A first pour of paraffin is added in the mold in the hot zone. The sample is then added inside and the mold is placed in the cold zone in order to fix it better. The biocassette is placed on top and left solidifying. Then the biocassettes are matched to be entered into the file of the APSIS system and stored by number. There is another kind of inclusion, automatic one, called Sakura. We insert a particular kind of biocassette and then the biocassettes are matched into the program of APSIS system. Then the biocassette passed to the cutting room.
Here we are in the processor room. The laboratory technician performs the maintenance of Donatello processor by replacing its reagents, removing its waste, and carrying out its washing. First, change the reactives and scan by the machine. The reactives are then stored in a safety cabinet. The cutting of the slice represents the final stage of the whole biopsy process. In the cutting room, our tutor shows us how to cut and we collect the slice on the slide. Through the rotative microtome, I cut a thin slice of the paraffin block. The slice must be a few microns thick. The slice is then picked up with brushes and put in hot water before being placed on a slide.
Once the racks are full, we insert them in the coloring machine. When the coloring is over, the slices are placed on panels and let dry. At the end of the process, the slides are left for the pathologist to be observed.
Okay, and now Anselmo. Anselmo is our student of the second year. We have just 1 year this year because we are inter-Ateneo. It means that we share with another university the course. 1 year is activated in Trieste and the following in another city. So now we have only the second year, and Anselmo will explain you the first 2 years of the course very shortly, okay?
Good afternoon. My name is Anselmo. I'm a second year student of the Biomedico Laboratorio Tecniche study course here in Trieste. On behalf of my colleagues, I would like to welcome you here in Trieste, even though I know you've been here for quite a while. Therefore, I hope you had a good time. I hope you had a good stay. And foremost, I hope that You had the opportunity to learn a lot in the facilities that our university offers to its students, especially in the healthcare profession departments. So for the next 10 minutes, I'm going to show you a brief presentation about the way our study course is organized, especially in regards to the internship, the classes, how a typical day works for us. So, of course, the aim, the objective of this study course is to form healthcare professionals with in-depth knowledge of laboratory sciences and techniques. So basically of how a laboratory works, what it means to carry a certain amount of responsibility inside a laboratory in terms of samples, the suitability of a certain sample, the analytical process through which the sample will go through, and the outcome that this analytical cycle will produce in order to elaborate a certain diagnosis. The study program has a duration of 3 years. Of course, as future, hopefully, biomedical technicians, we need to learn to guarantee the correct functioning of the machines that are used to carry out the analysis. We need to guarantee the ordinary maintenance of these machines. And of course, we need to eliminate minor problems whenever it's possible. Therefore, quick thinking and problem solving, of course, alongside scientific knowledge, are two qualities that are very highly appreciated in this kind of profession. Of course, this degree offers the chance, once it's completed, to work both in public and private laboratories, as you may already know. Throughout the 3 years of this study course, the student must learn to work autonomously in analytical and research laboratories, performing analysis in a very wide number of fields. I wrote down a few examples here, but of course, as you may already know, the number of fields in which laboratory technician can perform is pretty much massive. Of course, these professional competencies are developed through a curriculum that includes, of course, preparatory subjects, such as chemistry and physics, biological subjects, such as physiology, molecular biology, and genetics. And of course, we have the more advanced ones. The further you go, the more specific it becomes. Of course, this knowledge is integrated by solid grounding in what we call them the specific techniques that each laboratory has. And that, of course, are learned together with biocomputing methods that are used in each laboratory to organize and, to consult data or results from previous analysis. This is what a typical day for us looks like. Of course, there are some differences compared to the first year. Last year, we were attending internship in the afternoon as well, sometime. This year, we performed the internship mostly in the mornings. So it typically starts at 8 o'clock and it ends at 1 o'clock. We then have a lunch break of 1 hour. And then, of course, we have classes, which are mandatory, from 2 o'clock to 4 o'clock or 6 o'clock. It really depends, except for Fridays, where, of course, we are free to study. As I was saying, frequency of both is mandatory. So frequency of both the internship and classes is mandatory. For classes, we are allowed to skip up to 25% of classes. This is a very demanding study course. Therefore, frequency is highly required in order to learn in the best possible ways the concepts that will later be used throughout the internship. For those of us who have received positive reviews in all the different laboratory facilities throughout the year, of course, the students will be admitted to the final exam, which usually takes place in September. Once the final exam is passed, access to the following year is granted. The theoretical exams for the subject then usually take place in 2 windows, so January, February, and June, September. With an extraordinary window that takes place around the month of April, say. These are the laboratory facilities. that are offered to the students, not only for us, but for the healthcare professions department in general. So we have the Catinara Hospital and the Maggiore Hospital. We performed and we are performing most of our internship in these two hospitals. Then we have the Burlo Garofalo, which is mostly a pediatric hospital, so for pregnant patients, and especially for children that are affected by rare genetic disorders. So I decided to put a little insight about the first year. Of course, I like to remember the first year as with a bit of surprise. We had our first approach to the secretary room. I must admit that many of us didn't actually know that the laboratory technician is actually in charge of the opening, the eviscerating, and the sealing of corpses. So for many of us, it was quite a surprise, and it was a pretty big obstacle that we had to, face. It was around 13 weeks long, so for a total amount of 325 hours. What were the crucial points of this internship? Of course, great importance was given to the pre-analytical phase. Therefore, the modes in which a sample arrives to the laboratory. So the sample suitability, for example, is this sample clotted? Is it hemolytic? How can this interfere with the analysis that I will eventually carry out or not? The learning of the whole analytical process, from the collecting of the sample to the production of a certain outcome that will be used by the doctors to produce a certain diagnosis. Of course, the role of errors, so systematic errors, so that are produced systematically, for example, by the machines, and casual errors that are more unpredictable, that are caused, for example, by the technician, by the laboratory technician. Of course, we have the learning of the whole validation process. What is the clinical validation? What is the technical validation? Who performs what? And then, of course, we have a critical point, that is the quality checks and the calibration. When do we have to perform quality checks? For example, in an emergency laboratory, quality checks must be performed at least twice a day in order to guarantee the correct workflow throughout the whole day. Of course, we had the frequency of preparatory subjects, as I said before, to lay ground for the more specific subjects that will eventually come later. So these are the laboratory facilities in which we have and we are currently attending our internship. We have the Hematology Lab, Cytology and Histology, of course, that I'm sure you have already delved into quite enough. Microbiology, clinical chemistry, transfusion, and the emergency laboratory, whether it's in Maggiore or in Catinara. Each laboratory session had and has a duration of 3 weeks each, for a total amount of 550 hours. So I'm sure you have already learned a lot in this context. Of course, in general, the aim of pathological anatomy laboratory is the diagnosis of diseases based on the examination of organs and tissues, of course, in general. We have the setup of the samples that are collected, for example, in the autoptic room, according to optimal technical procedures. We have, of course, as students, of course, we learn to perform techniques that are typical from that facility, such as the execution of Gimsa and Papa Nicolau staining techniques. The Gimsa, of course, is performed manually, while the Papa Nicolau staining is performed with the use of the machine, as we've seen throughout the video. Then, of course, we learn, but this, of course, goes in general for laboratory facilities, the management of requests and acceptance of requests. And then, of course, we have the huge role that Trieste plays in the screening for HPV and the pap smear. We have 2 levels of screening, the first level and the second level. The first level is centered about the execution of a pap test for women between the age of 25 and 30, HPV for women with the age above 30. Any conditions outside of this is second level screening. Then, of course, we have the setup of samples for histological exams and the mounting of microscope slides, as we've previously seen. Then we have the microbiology lab. So, of course, what is the objective of this internship, at least for the student? The student must learn to detect with the naked eye some of the most common bacterial species. I put two examples here on the same growing medium. We have the CPSE, which is a growing medium used for the diagnosis of urinary infections. Here on the left, you can observe colonies of Escherichia coli, which usually appear pink and really thick. While on the right, you can observe enterococci, which usually appear greener and smaller, of course. Therefore, the student must learn what the main culture media are, both solid and liquid. So what, for example, a nutrient broth is, and in which circumstances is used, for what kind of sample is used. And then, of course, we have the chance to learn the execution of basic laboratory procedures, such as antibiograms, such as the Kirby-Bauer method, and the lateral flow immunoassays, test immunochromatografici, such as the one for the Clostridium difficile. I decided to put a picture of the Malditov as well. So it's the matrix-assisted laser desorption ionization time of flight, which is one of the machines that we learned to practice with this year. So it basically, as you may already know, it applies the principle of mass spectrometry. The sample containing the bacterial or the fungin species is fractured, and the signal is then compared to the signals already present into a pre-existing database. And then, of course, the outcome is expressed in terms of percentage. So what bacterial or fungin species is most likely to be in the sample. Then we have the clinical chemistry. We performed it both at the Maggiore and the Cattinara hospital. Of course, they are different because Cattinara is more like an emergency laboratory. So it's operative 24 hours. So the student must learn how to manage routine and emergency requests. And as I was saying before, the sample suitability. But sample suitability, of course, is a concept that goes for all types of laboratories, even in laboratories such as transfusion, as we will see now. So whether a sample is hemolytic, jaundice, italico, or lipemic, whether it's clotted or not. Then, of course, we have to carry out the basic maintenance of the analyzers, such as the substitution of reactives and the removal of wastes, the validation process, the types of tubes that are used to contain the samples, such as the purple one containing EDTA, and of course, relative additives that are contained in each tube. And then, of course, the execution of calibrations and quality checks. I decided to put a few examples of the machines that we usually use in these types of laboratories. We have the AU series, which is based on spectrophotometry and is used to determine the concentration in the sample of, for example, potassium, calcium, chlorine, sodium, and so on. We have the DXI, which performs immunoassays. So it's based on the interaction between antigens and antibodies, and is used, for example, for the detection of troponin, which is a cardiac marker, as well as of hormones, such as the TSH. And then we have the Liaison XL, which performs immunoassays as well, but mainly in the field of virology. So, for example, in the case of HIV, HPV, so it's able to detect, for example, the most common antigen, such as the antigen Australia, in the case of the HPV. Then we have the transfusion laboratory, Perhaps this is the laboratory with the highest level of legislation and responsibility. I think that the reason is pretty clear. Of course, the student must have really clear the concept of compatibility between donor and receiver. Throughout the 3 weeks, the student learns how to perform basic procedures such as cross matches, Coombs tests, such as the direct and indirect. So the direct is used to detect antibodies attached to the surface of red blood cells, while the indirect is used to detect antibodies that are free in the serum or plasma of the patient. And of course, the blood type determination. In case you do not know your blood type and you happen to be in that laboratory, you can perform it on yourself. So, The Flexis is the machine that is used for this analysis. They can both be performed manually and by means of the machine, of course. The students will also learn the modes of storage and transport of the different blood components, as well as the preparation of collyrium serum, which is a blood derivative and is used to correct eye disorders. Then we have the hematology laboratory. So as students, we have the possibility to learn the operating principle of the XN 9000 and of the hemogas analyzer. So the X 9000 performs various types of analysis, but most importantly, gives you, of course, basic information about the number of red blood cells, white blood cells, platelets with distribution, and so on. While the ABL 90 Flex, of course, is used for the hemogas analysis. The sample usually must arrive in ice in order for the different analytes not to be altered. This is an indication that must be strictly observed by the personnel. Otherwise, the sample cannot be accepted. Of course, we have something very interesting, that is the manual execution of blood smears, as you can see, especially in the case of the May-Grunwald-Giemsa staining technique, which is performed manually, of course. And of course, as I was saying before, the blood count measuring, which is performed by the XN 9000. I hope you enjoyed it.
Any question?
Very, very clear.
We have the first experience to a connection between two universities to show our activity to the students of Porto and to introduce the traineeship. And we have prepared a new lab, perfectly safe for formalin, because you have seen that the lab is in a vacuum atmosphere where formalin is controlled with the sensor, and any activity that increases the formalin in the lab send me alert, okay? And this is very useful for the technician because they are so very clever in the manipulation in different moments of the activity, and to improve a culture of safety. I think this is very important because in European law, formalin is declared as cancerous, and so we have to improve our skills and prevent exposure, also for our students and for our technicians and residents that works inside the labs for more than 5 hours per day. And I think also other substance as alcohol, as aromatic xylol, for example, have to control in the lab to reduce the exposition of all of us. In our hospital, only in anatomic pathology lab, we have formalin, not in other place, not in surgical room. not in the labs, in the ambulatory activity, only in our labs to reduce the exposition of all other workers. And I think this is one of the first laboratory in Italy to have the monitoring 24 hours per day, all the day in the year. And I think that it is a basis of a culture to stay in a safe place. We are happy to receive your students during these years because it is a good moment also for our students and for our technicians to meet and to have a comparison of activity and to discuss together during the day of the different possibility to work. For example, in Italy, during the last 2 years, our state discovered that we have little number of technicians in our hospital. And so next year we extended the number of enrolling students from 20 to 40. In fact, next year we have 40 students at the first years because we need technicians to employed in our hospitals because there are few number of technicians in Italy. We have attempt to discuss with our ministry that in the future we will need more expert in this field, but only with pandemic they have touched with hands this importance to have students and next technicians experts in this evolution of technology in our hospital.
Professor Fernandez, do you want to share with us your presentation?
Yes, please. First of all, thank you for the possibility to attend to this share of experiences. It was very nice to hear our students and your students with different points of view. I will briefly show you our degree. First, I will present the Polytechnic of Porto. That is a very big institution with more than 20,000 students in 9 different institutions under 58 different undergraduate programs, which are distributed in the north of Portugal in 3 campuses. This is the Asprela campus, where we are located. We are here in the H letter, very close to the Portuguese Institute of Oncology, Hospital de São João, that is a very big hospital in Portugal. But we are also together with Institute for Research and Innovation in Health and other faculties, more than 20 faculties nearby. So we usually say that we are in the square kilometer that produces most science in Portugal. So we are very well located. And this is our White House, our School of Health, where we can host maybe in the future your students. We have 12 undergraduate courses, 12 master degrees. We have more than 2,500 students, and we work in 2 different research centers. CISA is devoted to the health and environment research, where I belong to. And then we have also the Rehabilitation Center. We have been enrolled in different Erasmus Plus projects. Nowadays, we are working on a blended intensive program that prepares young undergraduate women for a research career that will start in 2022. Maybe I can share more information with you later. Our students can also use the mobile unity we have crossing the city and the country to render services to the society. For example, under consultation for audiology, speech therapy, orthotics, and also in some sensibilization to the community. And here our undergraduate degrees. I highlight obviously the Biomedical Laboratory Sciences, which is our degree, which I will very briefly present to you. It has a 4 years duration with 240 credits, and it confers the qualification for the autonomous profession exercise into different careers, the clinical analysis and public health technician, and the pathological, cytological, and tonatological anatomy technician, which are in Portugal two independent professions. Our degree also allows the access to the level 6 of the European qualification frameworks, which enables our students to work at the European and global level, and also at the Catinara Hospital. Since you are needing technicians, they can also work there. So our degree is based essentially on the Biomedical Laboratory Sciences technical scientific area, but we have also some transversal subjects like morphological sciences, biochemistry, chemistry, physics, and biomathematics, which are essential for the total curricula of our students. Year by year, so the first year, we have essentially those transversal subjects: biostatistics, histology, psychology, chemistry, biochemistry. And we have the introduction to the profession and also two very small subjects, so the students can get in touch with the core of the course: cytology, a laboratorial one, and also the microbiology in the first year. In the second year, we have essentially the specific subjects like histotechnology, immunology, pathology, clinical microbiology, and so on. And we have also the management and quality in biophysics. And in the third year, we get continuity with virology, forensic pathology, cytology, screening, and we start our clinical education, a very small traineeship in this third year, which gives continuity to our fourth and last year, where the students are essentially dedicated to the traineeship, internship in different hospitals, clinics, and laboratories. And also they work and develop the thesis, the final project in biomedical laboratory sciences. Concerning specifically to the internship, our students have 15 weeks of traineeship in the clinical analysis areas like microbiology, clinical biochemistry, immunology, hematology and transfusion, and hematology. They have also 15 weeks in pathological areas like gross anatomy or macroscopy, histopathology, histochemistry, cytopathology, and immunohistochemistry. And they have also the possibility to choose one of these areas, a more specific area, to make a traineeship of 3 weeks where they can eventually develop their thesis. So in total, our students have 33 weeks, full-time weeks in traineeship, 3 weeks in the third year and 30 weeks in the fourth year. And they have also the possibility to go abroad and make part of the clinical education under Erasmus program. Here are the list of partners we have nowadays. The first one is our favorite, but we have also students in other parts of Italy and Brussels, and also the possibility of Finland and Austria. So if some of our students can apply to a master's degree, we have those master's degrees, and I highlight those ones that are more related to the health area, which could be interesting for you. And in our clinical, technical, scientific area, pathologic anatomy, we have ongoing this master degree with 3 different branches: molecular pathology, histopathology, and cytopathology. And if you have some questions, you can use this address. And in this such a embracing and comprehensive course, I would like to tell you, students, that it's up to you to choose the area you most like and where you want to work, because you have the possibility to have a lot of different areas. I choose cytology, and I would like to thank you very much for your attention, and I hope to see you in Porto.
Thanks, Silvia. Very clear explanation of the course. Thank you very much. If the students have any question?
I think could be an interesting moment to have a meeting at the middle time of the traineeship of the students, to have evaluation of the activity and to improve in the next future other activity. It is, I think, not simple in the first month when you have all new in a new place with different colleagues, but I think at the end it could be more simple to introduce you with the other person and to start to work in autonomy. And I think this is a very good experience, as I suggested before. I'm very happy that our students have the opportunity to see your Polytechnic or your labs, your activity, because I think it could be important to improve our changes. Not only students from Porto in Trieste, but also students from Trieste to Porto, as Ricardo, that follows the 3 students during this month. He was in Porto for 6 months, if I remember, 3 years ago, I think, and now works in our labs. Okay.
Yes, I remember Ricardo. Oh, our trainers in the traineeship loved Ricardo. He did very well. I think it was a very good experience.
Yes, he's very nice and polite and very curious.
I think the hospitals, if I ask if they remember, of course they will never forget. Ricardo was very, very well received and very well done.
Okay, I think it's all for this very nice day. I have to do the compliments to all the students, yours and ours. And I think it has been difficult for you for first experience to do these videos. And thanks to Dr. Santopietro for the support. I think it's without him, it was impossible to do this work. So thanks to all. Thanks.
Okay. Thank you.
Thank you.
Thank you, Silvia.
Nice to see you, and
Thanks.
hope to go again in Trieste in the next Erasmus teaching training or something.
Thank you.
Thank you very much for the opportunity. Thank you for receiving our students, and thank you for your nice reception.
Thank you again.
Bye-bye.
Nice afternoon. Bye-bye.
Bye-bye.